we will explain the trend in what atomic radius. Okay, so when we are moving from left to right across the periodic table, let's say from left to right across the periodic table, atomic size what decreases. Atomic size decreases when we are moving from what left to right, something like this, across the periodic table. The atomic radius decreases. So moving from left to right, that is across the period, the size decreases. So let's take lithium, for example, lithium. Let's say this is lithium atom, lithium, and followed by what? Beryllium. So let's say this is beryllium atom, Be. So followed by what? Boron. So let's say this is boron atom, B. Followed by what? Carbon. So let's say this is carbon atom, followed by what? Nitrogen. So let's say this is nitrogen atom. So when we are going like this across the period from left to right, the atomic what size decreases. So the question is why? Why is it that the atomic size what decreases when we are moving from left to right? So let's try and understand that and see how we can do that. Okay, so I told you first that when explaining this, first we take what number of what uh, number of protons, and I told you that is what a nuclear charge, and the second one I told you to take what number of shells. Are you getting me? You take number of shells. So for lithium, for example, is atomic number three. Atomic number three. So I will do something here. Let me say this is three plus. I will just do something like that. And this beryllium will be four. So I'll just say four. And I think this is five. Six. No, no. Let me see. Lithium is three. Beryllium is four. Boron is five. Okay. So this is nitrogen. This is nitrogen, which is seven. Okay. So when we are moving like this, let's take the shells. You can see boron, which is atomic number three, having hot, two eight, and this is hot two one, and this is hot two, this is hot two three, and this is two four, and this one be two five. So you can see all of them will have what two shells, two shells, two shells, two shells. So when we are moving across the period, the electrons what enter into the same shells. Enter into the same shells. And that is why I told you that when you are talking about shells, we talk about screening effect. So we say what the screening effect is what constant. So anytime you are talking about shell, that bring about the screening effect or the shielding effect. So what the shielding effect is what constant. So that means there will not be any shielding effect what uh, disturbing this. And you know what is shielding effect is what we talk about. Let's say inner repulsion of electrons. Inner repulsion of electrons. I will explain that to you later. So let's take the second point. So for the second point, when we are moving like this, the atomic number increases. That is why you see lithium is atomic number 3, 4, 5, 6, 7. So the atomic number increases. So if the atomic number increases like this, what will happen? And I told you the atomic number is the same as proton number. So proton number increases. That is why I put it to bracket nuclear charge. A nuclear charge is just a force that will pull the valence electron towards what? The nucleus. Are you getting me? So if the proton number increase like this, that means what? The nuclear charge will also increases as well as the effective nuclear charge. So let's take lithium for example. The nuclear charge of lithium is what? Lithium is atomic number 3, so that is 2 1. So lithium is what? Plus 1. That is the nuclear charge. So for beryllium, beryllium will be plus 2. So like that. Are you getting me? Like that. So you can see the nuclear charge will be increasing when we are moving like this. And the same as the effective nuclear charge. And you see this one, this is 3, 4, 5, 6. So, okay, when we have an atom like this, let's say this nitrogen atom and this lithium atom. This is the nitrogen atom here, nitrogen, and this lithium atom. And this one is what? 3. 3. I will make this one, this is 7, so I will just do this plus 7, and this one plus 3. And we have nucleus here, nucleus here. Okay, see this. Check this. This nucleus and this nucleus, which one will pull the valence electron towards itself more strongly? Let's say we have a valence electron here. a valence electron here. Okay, since the charge of this one is higher than this, you can see this nucleus will be able to pull this valence electron towards itself more than this. Are you getting me? This one will be able to pull the valence electron strongly towards itself more than the lithium, because the charge of this one will be hot higher than the charge of this. Are you getting me? That is the effective nuclear charge. It will be higher than this. That is why as it pulls this one strongly towards itself, this one will come closer to the nucleus. So it will make this one more smaller than this. Are you getting me? So for example, let me take beryllium and boron. And let's say this is beryllium, this is boron. And you know this one is 4, this is 5. That is the atomic number 4, this is atomic number 5. Okay. So atomic number is the same as the proton number though. So let's take we have this nucleus here and we have a nucleus here. And you can see this one have a higher proton number more than this. Are you getting me? So you can see this nucleus will be able to pull the outermost electron toward itself more than this. Are you getting me? So the force of attraction between this and this will be higher. So you can see the one having the higher charge will attract itself more to the nucleus, so making this one smaller than this. That is why we say when we are moving like this, from across the period, the atomic size will decreases, because first when we are moving like this, electrons enter into the same shells. Yeah, this is the same shells, because they all have two shells here when we consider these ones. So the screening effect is what constant. But when we are moving like this, you can see the number of protons are increasing. So as the number of protons are increasing, what effective nuclear charge increases, in the same way as what the effective nuclear charge. So if the effective nuclear charge increases, that is what, and I told the nuclear charge talk about attraction. So the valence electron are hot, pull strongly, pull strongly towards the nucleus. Are you getting me? They are pulled strongly towards the nucleus. So that will lead to what? Decreasing size. Do you understand? That will lead to decreasing size. So we go on to talk about what when we are moving hot down the group, something like this. So when we are moving down groups, we see that what the atomic size what increases down the group. So I will take the periodic table like this: lithium, sodium, and potassium. Let's see when we are moving down the group. The reason why we say hot, the atomic size what increases. Let's take this. Okay, so let's say this is lithium, which is atomic number 3. So lithium, and okay, let me do this here big so that you see this lithium. So lithium is atomic number 3, so I will just draw 2 1 here, and we'll go to what? Sodium. So sodium is 11, so 2 8 and 1. Okay, so we'll go to what? Potassium. Potassium, which is what? 19, so 2 8 8 and what? 1. Okay, so this is lithium, sodium, and what? Potassium. Okay, and we say when we are moving like this, the atomic size what? Increases. Let's check the reason why. Okay, so when we want to use energy levels, the energy levels just talk about the number of shells. So you can see lithium having what? Only 2 shells, 1 2. So the energy levels here is what? 2. Are you getting me? The energy levels here is what? 2. And when you come here, this one is what? 1 2 3. So the energy levels here is 3. Are you getting me? When we are talking about energy levels, and the energy level in potassium is what? Will be what? 1 2 3 4. So the number of shells here is 4. So the energy levels is 4. So you can see how the energy level is increasing: 2 3 4. So while we are moving down the group, you can see the size of the atom will be what? Increasing, increasing, increasing. Okay, let's check these two. Let's take the number of protons here. The proton number in lithium. The proton number in lithium will be what? the same as the atomic number, which is 3, and the same as the electron number will be 3. Okay, and this one, the sodium will be what? 11, and the electron number will also be 11. Proton number of potassium will be what? 19. Electron number will also be 19. Okay, so we can see this place. The ones having a higher proton number, there will be a higher force of attraction there. But when we have a higher force of attraction there, that is supposed to draw the outermost electron closer to itself to make the atom small. But we have a problem here, that is what we call the shielding effect. And I will explain it to you here. This is potassium. This is 2. This is 2. And this is 8. This is 8. Okay, and we have another 8 here. And we have 1 here. 1. Okay. So when we are talking about atomic radius, we consider the valence shell. We consider the valence shell. Okay. So you can see this. Let's say this is the nucleus here. So if the nucleus want to pull electron from the outermost shell, let's see something. See, I want to remove this electron, this, and see the electron we have here. The electron we have here. We call this what? Shielding effect. Shielding effect. Are you getting me? So once I want to remove this electron here, you can see we have some 2 electrons here which will prevent me from pulling this. Are you getting me? So once I want to pull this, you can see this is also shielding. It's like these 2 electrons. So how can I this proton ma electron yala haya hala haya tutun kwa imegbe ele tutun cover kwa ide megbe. You see, how can ma home of higher calafia higher to megbe. So you can see the size of the atom will be what? Increasing, increasing, increasing. So that is what we call shielding effect. That is what we call shielding effect. But if, for example, this thing, for example, okay, so for example, we have 1 and 1 here. There will not be any screening effect because they are of the same mass. So this cannot pull this. This one cannot pull this. But you see here we have what? 1, 2, and this is only 1. So this mass here is what? Higher than this. So you can see once I'm trying to pull this can equally try to pull this away. So once this one is trying to pull it in, this here can also try to pull this one away. So you can see the size of the atom what? Increasing. So that is what we call the shielding what? Effect. And let's draw this and see. The second one, which is what? Sodium. Sodium. So the first one is 2. And the second one will be what? 8. Second one will be 8. And the last one will be what? 1. So let's take this one too. But take note, this one have 1, 2, 3. This one have 4 shells. So the shell is 4. And this one have 3 shells. So see. So once the nucleus want to remove this electron, you can see this one having some 2 this thing here. This will be preventing the nucleus from attracting this. It will prevent the nucleus from attracting this. So this will also be what? Pulling this one back. While this one is trying, the nucleus is trying to pull the outermost electron. The 2 electron here will be trying to what? Pull this one also away. So you can see that one will also be increasing. Are you getting me? So that is what we call shielding effect. But for lithium, let's take lithium. 2 and 1. 2 and 1. So see, this one have for only 2 shells. And this is the outermost electron here. This is the outermost electron here. So once I'm trying to pull this here, see this is only 1, this is only 1. You see they are the same mass. So once I'm trying to pull, I can pull it easily. So once I pull this thing easily, this atom will become what? Smaller. You see? Higher got swayed because then when your nucleus are filled, matter pulling. I don't have any stress because this one, they of the same mass. So matter pull it over the queen and come over to there. But when I come here and in nucleus, you have a map pull hey. Electron mo very la fear. Once go map pull the queen and la higher cannot higher pulling quite my bed. Kevin one can size ala, egg are no increasing. So that is this what we call the shielding effect. Shielding effect. Shield, normal English. So that is the inner repulsion. And you know, electrons they are negative, negative. Are you getting me? So they will be repelling each other. Are you getting me? There will be repulsion there because negative, negative. There will be repulsion. So this thing, one, two, and this one. So you can see the mass of this one is higher than this. So once I'm here trying to pull this, I can never pull this to come closer to the nucleus because we have something here that will be repelling it. So you can see this side, this one will be going higher. It will be going higher. So the size of this one will be increasing. Same as this. Same as this. So you can hear the shells are hot. One, two, three, four. One, two, three, four. So you can also see one here again. One, two. You see? So once I'm here, I'm trying to pull this. You can see these two. They will be trying to pull this one away again. So this one will also hot, be bigger than this. This one and this one will also be bigger than this. And when you consider the energy levels, you see this one have only two shells. One, two. And this one hot one, two, three. And this one hot one, two, three, four. So you can see what I'm talking about. So when we are going like this one, the size will be what? Increasing. Are you getting me? When you are going like this, the size will be increasing because when you consider the number of shells, that is the energy levels, you can equally notice that when I draw two shells here and I draw three shells here, four shells here, which one will be bigger? Just normally my understanding, you can see this one will be bigger. Are you getting me? So equally, this is what? Bigger than this. So when we are going down the group, the atomic what? Size increases. So first, going down the group, what happened? I told you that when we are explaining atomic radius, take consideration of two things, and that is what number of hot protons, the atomic number, and the number of shells. So when we are moving like this, what happened? The number of shells what increases. So the number of shells what increases. Okay. So when the number of shells increases, I told you shell is linked with shielding effect. So you can see shielding effect also increases. That is why you can see something here. Here, I don't have any shielding effect. But when I have here, I come here, this is one. This is the outermost electron. But when I come here, I have two electrons shielding it. So this is two. But when I come here, you can see I have two electrons here. And I still have two electrons here again. Are you getting? So that means the shielding effect is what? Increasing. Are you getting? The shielding effect is what? Increasing. Yeah. So when the shielding effect increase, shielding effect means like inner repulsion. Inner repulsion. Okay. So the same way when we are going down the group, the atomic number increases. That is the proton number increases. And I told you proton number is linked with what? Nuclear charge. But though proton number increases, the effective nuclear charge will rather decreases because of the screening effect. Yeah, and I told you if a nuclear charge deals about attraction of the outermost electron to the nucleus. And now we have shielding effect here. Can this attract it? It can never attract. Yeah, it can never attract because since I'm trying to attract, this will be repelling it. This one will be pulling it backward. You see, the two will be pulling it backward. So what the nuclear charge will what rather decreases. It will rather decreases. So these are the things that are making the size of the atom what larger. Are you getting me?